Around 2500 BCE, a civilization emerged in South Asia, covering 1.5 million square kilometers, stretching from the Arabian Sea to the Himalayas. If you combined the territories of ancient Egypt and Mesopotamia, they would still fit comfortably inside the Harappan footprint. Across this massive expanse, the Harappans built over 1,000 settlements. Their mega-cities housed up to 40,000 people, laid out on mathematically precise grid systems. They engineered covered drainage networks and dug hundreds of standardized wells to deliver fresh water. Yet, if you walk through these ruins looking for the familiar markers of the ancient world, you will find a glaring absence. There are no monumental palaces. There are no royal tombs. Archaeologists have never found a massive statue of a god king. Despite operating without an autocratic ruler, this society maintained exact standards across thousands of miles. A merchant in the north and a trader on the coast used the exact same binary system of cuboid stone weights to measure their goods. A continent-spanning trade network requires immense coordination. The Harappans achieved this physical and economic scale through highly decentralized, integrated societal organization, sidestepping the need for top-down authoritarian rule. To manage this global economy, merchants authenticated shipments using finely carved steatite seals. Carved above the animal figures are over 400 distinct characters, a highly structured written language. After a century of study, no one can read a single word. Around 2200 BCE, this stable society encountered a severe environmental crisis. A planetary climate shift disrupted the weather patterns that sustained their crops. We cannot read their administrative records to see how they reacted, and no royal monuments dictate their perspective. To reconstruct their response to this existential threat, we have to look past the written word and learn to read the earth itself. Scientists reconstruct ancient weather patterns using paleoclimatology. By extracting core samples from the earth and analyzing the chemical signatures trapped inside, they can read the exact moisture levels of the atmosphere from thousands of years ago. This chart tracks the strength of the Indian summer monsoon using oxygen isotope data and pollen cores. The data shows a stable period of high rainfall supporting the civilization's growth. Then, right at 2200 BCE, the rainfall levels collapse into a severe, multi-century drought. As the monsoon weakened, the regional hydrology failed. The massive Ghaggar-Hakra river system, a well-watered corridor that concentrated many of the largest Harappan cities, narrowed, became seasonal, and eventually ran completely dead. This was a permanent geographical transformation. The predictable floodwaters that replenished the soil and filled the city wells were gone, destroying the physical infrastructure that allowed dense urban populations to exist. To see how humans responded to this drowning landscape, we have to zoom in to a specific farming settlement in Haryana called Farmana. Here, researchers use archaeobotany, the microscopic study of charred seeds and plant remains, to track the exact crops the Harappans chose to plant. This stacked bar chart isolates the plant remains found in the 2500 BCE excavation layer at Farmana. At the civilization's peak, the food supply relied heavily on winter crops. Wheat and barley dominated the fields, accounting for 61% of the harvest. As the chart updates to the 2000 BCE layer, the impact of the failing monsoon becomes visible. The cultivation of water-heavy wheat and barley plummeted to 20%. In their place, the farmers rapidly expanded the cultivation of alternative summer crops. The primary replacement crop was millet. Millet produces a lower caloric yields per hectare than wheat, but it is highly drought-resistant. It survives and produces food even when the rains are sparse and erratic. No central authority issued a decree to change the agricultural base of the continent. Thousands of local farmers looked at their thinning wheat fields, read the changing conditions, and independently adapted their crops to survive. The archaeological record contains no mass graves, no burned infrastructure, and no evidence of military conquest. The civilization did not suffer a sudden apocalyptic collapse. But shifting to millet forced an economic reality. Drought-resistant crops fed families perfectly well, but they could not generate the massive agricultural surplus required to sustain a dense, centralized city of 40,000 non-farming artisans and merchants. This map charts the settlement patterns over time. The dense megacities slowly unspooled. The population dispersed. breaking into smaller, highly numerous rural communities that migrated east toward the Ganges Basin, tracking the remaining reliable rainfall. The people survived by abandoning the structures that no longer served them. They traded vulnerable, water-hungry megacities for resilient, self-sustaining agricultural networks. Dispersing into small farming villages solved the immediate crisis of survival, but it removed the need for complex urban administration. The specialized workshops emptied out. The maritime trade routes closed. Highly crafted goods, like these etched carnelian beads, stopped flowing into the ports of Mesopotamia entirely. Without long-distance commerce to regulate, the merchant seals lost their purpose. The script that recorded the civilization's economy was abandoned, taking the spoken language of the Harappans with it into silence. The Harappans left no massive statues to project their eternal power. Instead, their legacy is documented in the seeds they chose to plant. When the climate turned against them, they relied on collective knowledge and local adaptation to ensure their descendants would survive.